Welcome back to Inorganic Tutors Institute. In today's lecture, we are basically going to look at episode 6, right? Where we look at 3 set problems, right? And we are still under the big umbrella union and intersection of set. Union and intersection of set. So basically, from the previous episode, we learned how to solve problems using or involving 2 sets, right? We learned how to solve problems involving 2 sets, and we basically use the Venn diagrams, right? And we saw how to find unions, intersections, and elements outside the sets, right? That is what we did in episode 5. Okay, now we are going to extend this particular idea further, right? So that is where the 3 set problems comes in. And so instead of the 2 set, we are going to talk about a 3 set in this regards. So with this, it will help us to solve real exam problems. It will help us to solve problems that involve 3 skills, or it will help us to solve problems that involve 3 activities. Okay, so that is what the 3 set problem is going to help us to do. Now, this particular method is basically the same as the 2 set problem, right? It's basically the same. What is different from here is just that the understanding or the concept is a bit deeper than the 2 set problem. All right, the idea or the method is the same. The idea or the method is the same. So if you really understood the 2 set problem, then this shouldn't be a problem at all. This shouldn't be a problem at all. So we are basically going to extend the 2 set problem to the 3 set problem. So recall from episode 5 or from the 2 set problem, we know that, okay, so recall that in the 2 set problem, in the 2 sets, we had 4 regions, right? In the 2 sets, we had 4 regions where we had this, right? We had this, and this is region 1, region 2, region 3, and region 4, right? That is for the 2 set problem, right? But in the 3 set problem, we have 8 regions, right? It's basically 7, right? But then if you add the complement section, this particular section, it becomes 8, right? So with the 3 set problem, the 3 sets, we have 8 regions. We have 8 regions. And do you know one interesting thing about it? We are still going to use the words that we used in the 2 set problems, or the terminologies that we used in the 2 set problem. So we still use 1, the word only, right? So you're going to hear those terms again. And 2, you're going to hear something like intersection, right? So intersections. And 3, you're going to hear something like union of a set, right? So you look at union of a set, and then you also hear something like complements. So complement, right? So these are the terms that we heard about in the 2 set problem, right? And they are the same things that we are going to hear in episode 6, which is the 3 set problem, and just that this method is a bit deeper, or the understanding is a bit deeper than the 2 set problem, right? So from here, let's try to use the diagram to clarify this particular concept, right? So let's have our diagram. This is our Venn diagram, right? We have set A, set B, and set C, right? So this is called a three-set problem. This is called a three-set problem. So we call this set A, right? So this is set A, right? This is set A. So let's just name it A, B, and C, right? So set A, set B, set C, right? So how do we identify this? This is the whole of this section is set A, right? The whole of that section is set A. And the whole of this particular section is set B. The whole of this particular section is set B. And the whole of this is set C, right? The whole of this section is set C. So now we have three sets. Now, what are we going to do? How do we identify these regions, or what are we going to use to represent those regions? So basically, this particular region, you can see that this particular region is the region that is common to all the three regions, right? So this particular region, we call it A intersection B intersection C, right? So this region is the commonest among all the three. And so we call it A intersection B intersection C, right? And this particular region is the region that is common to A and B, right? So we call this region A intersection B, right? And when it comes to this particular region, this region right here, it is B and C that is common to that, right? So we call it B intersection C. All right. Then this particular region, this and this here is the common section, right? So the common section here is A intersection C. Right? The common section here is what? A intersection C. Right? So the common region between A and C is here. The common region between A and B is here. The common region between B and C is right here. Okay? Now, if you make an attempt to take the intersection, which is the common region to all the three sets, from this, then it becomes the only, right? So if we take this from this, then it becomes the A intersection B only. So we call this particular place A intersection B only. If you take the element that is common to all the three sets from this particular one, then it becomes only, right? Only. Then when you do the same thing to this, it becomes only, right? The same thing applies to this particular part here. All right? So it means that if you take the element that is common to all the three sets from the common two sets, then it becomes what? Only. When you do the same thing to this and that, it becomes what? Only. The same thing applies to this section as well. Now, before we come to this part, you have to understand this. So give it a thought and try to reminisce over this particular interpretation, right? Before you come to this part. Okay, so this particular part, if you take this particular part, this is where we call the A only. And that only happens when you take the number of elements and you take the common set, that is the element common to all the three sets from the number of elements for A, then it becomes what? A only, right? The same thing applies to B. When you take the number of elements in B or in set B from, when you take the number of elements that are common to all the three sets from the number of elements in set B, then that becomes B only, right? And then when you take the number of elements that is common to all the three sets from the number of elements in set C, then you have C only, right? So that is the interpretation of these seven regions. So we basically have 7 regions, but because of the complement, I just want to have the complement here, right? So we call this A union B union C or complement. So this particular section, they don't belong to A or B or C. They don't belong to any of the three sets, and so those elements lies outside the set. They lie outside the set. So the element that lies outside the three sets becomes the complement, and we denote it as A union B union C or complement. So that is this particular section. And when you add the element in set A, the element in set B, and the element in set C, you should, and then you add the complement, it should give you what? The universal set. So this is the universal set. The number of elements in all the three sets plus the complement will give you what? The universal set. Great. Now that we have understood this interpretation, now let's look at some analysis, right? So anytime, right, you use three sets, anytime you see three sets, or anytime you see three set problem, think of, most times you have to think of 7 regions, because sometimes you don't have any complement, right? You don't have any complement. But if the complement comes in, then you have to think of 8 regions. But if there is no complement, then you have to think of 7 regions, right? So it's either 7 or 8. So let's call it 8, right? Now, always do this when you are dealing with a set problem, right? Always start. So as I started with the common set that, or the common element that belongs to set A, set B, and set B, that is A intersection B intersection C, always start with or always start finding the diagram. Always start finding the diagram from the center. Always start finding the diagram from the center. So this is the center. That is the element that is common to both A, that is common to A, B, and C. And that is the A intersection B intersection C. So always start from the center. So if you start from the center, you realize that you take this from this, and then you get the element here. You take this from this, then you get the element here. you take this from that and you get the element here. So always start from the center, the common element among all the three sets. So A intersection B intersection C. Always start from that particular section. So we call it, that's A intersection B intersection C. This is where you have to start from always when you are dealing with a problem, a set problem. Okay, always start from the center. Whether you are dealing with a 2-set problem or a 3-set problem, start from the center. Start from the center is very, very important. It will help you to avoid errors. Now, I believe that we have been able to understand the concept and we can handle a problem to basically understand the whole concept about the 3 set, right? So give me some short minute. I'll be back with a quick problem so that we understand the concept of the 3 set problem. Okay, welcome back from the short break. I believe that you have been able to digest the concept and then you agree with me with all the explanations, right? Now, this is an example that I want us to use to clarify the concept, right? So the question says, in a group of 60 students, the number of, let's say, actuarial science students is 30. The number of biology students is 28, the number of chemistry students is 25, and the number of actuarial science and biology students is 12. The number of actuarial science and chemistry students is 10. The number of biology and chemistry is 9. The number of actuarial science and biology and chemistry is 5. Now, we want to find student who study only mathematics, student who study exactly 2 subjects, and student who study none of the subjects, right? So this problem is very, very simple. If you understand the diagram, you can get it done within 2 minutes, right? So let's start with the problem. Okay, so answer, right? We know that, so we have been given the parameters, right, as n of A to be 30, n of B to be 28, n of C to be 25, right? And then n of A intersection B is 12, n of A intersection C is 10, n of B intersection C is 9, and n of A intersection B intersection C is 5. Right. Now, let's base on this information to draw our Venn diagram. So let's have our 3 sets, right? So we have this set A, set B, and set C, right? So we call this n of A, which is 30, n of B, which is 28, and then we have n of C, which is 25, right? Now, what we learned from the beginning, from the onset, we said that always start with the center. Always start with the center, right? So if you start with the center, it will help you to avoid errors, right? So the center here is 5. That is the element that is common to all the 3 sets, right? Is 5. So we are done with the center, right? Now, the next thing you have to do is go to those that are having 2 common sets, right? So you go to A intersection B. So that is this part, right? So if you want to get this part, what do you have to do? You take the common set the element that is common to all the three sets from the number of elements in that, right? You take this particular one from the number of elements in the A intersection B, and we were given A intersection B to be 12. So if you take 5 from 12, you're going to have 7, right? That is how we get the only section. So once you do this, this element becomes A intersection B only. A intersection B only, right? Now, we come to this part, right? We come to this part. That is, we want to get this part, right? So we take this from B intersection C, and we were given B intersection C to be 9, right? So 9 minus 5 will give us 4, right? Now, we come here. We need this part, right? So we take A intersection C, right? And then we take the common set, right? The element that is common to all the three from A intersection C. And A intersection C was given as 10. So 10 minus 5 will give us 5. Beautiful, beautiful, beautiful. So now we have this section, we have this section, we have this section, and we have that section, right? So what is left? It left with only A, only B, and only C, right? It left with only A, only B, and only C, right? So how do we get that? Now, since we have been able to identify this, we have been able to identify this, we have been able to identify that, what we just have to do is to take this particular element, right? Then we subtract the whole of this 3 from that to get this section. Let me come again. If you want to get this particular section, you take this element, then you subtract this, that, and that from it. Then you get this element, right? So we are going to do that work in here. So we have n of number of mathematics, this is actuarial science, right? Number of actuarial science students only. So we call it actuarial science only, right? So that becomes n of A only will be equal to 30 minus 7 plus 5 plus 5. Right, so we have 30 minus 7 plus 5 is 12. 12 plus 5 is 17, right? So we have 17 here, right? So you take 17 from 30, right? We take 17 from 30, and then we have the only section for A, right? So this part becomes what? 12. So we have 12 here. Right? Now, we need this part. So what do? We sum all these ones, then we take it from the 28. So number of B only is equal to 28 minus 7 plus 5 plus 4. Right? So we have 28 minus 7 plus 5 is 12. 12 plus 4 is 16. Right, so we have 16 here. So we take 16 from 28, and then we have number of biology students only. Number of biology students only. Right, and that is 12 as well. That is 12 as well. Now, we left with this particular section, right? So we're going to do that here. So number of chemistry student only, and that is equal to 25 minus 5 plus 5 plus 5. 5 plus 5 plus 4, right? So we have 25 minus, this will give us 10. 10 plus 4 is 14, right? So 25 minus 12 is basically 11, right? So we have 11 here. So we have 11 here. 11 here. Okay, we have 11 there. So basically, if you find that of yes, this part is 13, right? 13 minus 17 is 13, right? So this is 13 and this is 12 as usual. So that is it for this particular problem. Yeah, that is it for this particular problem. So you can see that with the Venn diagram, we have been able to do the work very easily, right? Very easily. So if you want this section, all right, if you want this section only, you take this particular element, that is the center, from the intersection that you have been given, right? And we were given the intersection between A and B to be 12. So if you take 5 from 12, you have what? 7. And that becomes the only people that were between A and B. The same thing applies to the only people between B and C. You take the center from the number that was given, and that will give you what? 4. We do the same thing to A and what? C, and that give us what? 5. Now, with this particular section that we are much interested in, the only section, right? This is the section where we call it exactly one subject. Exactly one subject. This is the section. This section and this section are called exactly one subject. This, and this is called exactly two subjects. So this, and that gives you exactly two subjects. This, and that gives you exactly one subject. Okay? Exactly one subject. Exactly one subject. So now let me clean up this particular work so that we can conclude on this particular problem. So the question says that only actuarial science student, right? So only actuarial science student, you have only actuarial science student, you're going to have 13, right? Only actuarial science student, you're going to have 13. So only actuarial science student, we have 13 students, or we have 13. Then B, exactly two subjects, right? Exactly two subjects, we are going to have these particular sections, right? This, and that, all right? This, and that. So exactly two subjects, we are going to have 7 plus 5 plus 4. And that is 12 plus 4, 16. So exactly two subjects is this, and that. Great. C, if you are to find none of the subject, right? If you are to find none of the subject, that means that you are going to find or you can use the formula, right? If you use the formula, it means that you are going to say N of A union B union C will be equal to what? You sum all this, right? You sum all this. When you sum this, you sum this to this to this to this to that, you are going to get 57, right? You're going to get 57. And so you take that 57 from the universal set, and then you get none of the student. So when you sum all this element, you're going to get 57. So we have 60 minus 57, and that will give us 3. So none of the student will give us 3. right? None of the students will give us 3. So basically, that particular one, we note it as this particular section. That is this particular section, right? None of the students is this particular section. Right? We are using subject, right? So if we talk about none of the subject, the student is neither offering actuarial science or chemistry or biology. We had only 3 students. Only 3 students. And that is this section. That is why I was saying that we have 7 regions, right? We have 7 regions, but then if you add the complement section, those that are not part of set A, they are not even part of set B, they are not also part of set C, that is this particular section, the outside box, the outside set, right? The outside set. And we had that be 3 because the universal set was 60. Right? And when you sum 13, 7, 5, 5, 4, 12, and 11, you have 57. Right? So if you take 57 from 60, you have 3. So none of the subject is 3. Beautiful question, indeed. Beautiful question. So this is very, very simple. You see how simple it is when you use the Venn diagram to go about everything. Right? Now, I want to give you some short break, review the question, review the answer, and come back. I'm going to give you a quick practice problem, so give me some short minute. I'll be back. All right. Welcome back from the short break. I believe that you have been able to glance through the problem that we solved and you are good with it. Great. Now, since you are cool with it, I'm going to give you a quick practice problem that you enjoy at your comfort time, right? So, the question is, in a university department, 120 students offer at least one of the courses, right? We have mathematics denoted as M, statistics denoted as X, computer science denoted as C. Now, it is known that the number of students who offer mathematics is twice the number who offer statistics only. It is known that the number who offer mathematics is twice the number who offer statistics only. Okay. Now, the number of students who offer computer science only is 5 more than those who offer both mathematics and statistics only. The number of students who offer mathematics and computer science only is equal to the number who offer statistics and computer science only. Now, 25 students offer all the 3 courses. The number of students who offer exactly 2 courses is 15 more than the number who offer only 1 course, right? So, this is the question, right? Now, these are the questions that have been asked, right? How many students offer only mathematics, right? So, we need only mathematics. 2, how many students offer only statistics, right? So, we need only statistics students. How many students offer only computer science, right? 4, how many students offer mathematics in total, right? So we need mathematics students in total. 5, how many students offer exactly 2 courses? Exactly 2 courses. So that is question number 5. How many students offer exactly 2 courses? Then 6, verify that your answers satisfy all the given conditions, right? So you have to verify that your answers satisfy all the given conditions. Right? So this is the question. Write it, brainstorm, and try to understand. This is a word problem, a full word problem in set theory, right? So this is a word problem coming from 3 set problem. Okay, so understand the problem, solve, and leave your answer at the comments. At the comment section. The first 5 people to get the question right are going to win a big prize from me, right? A cash prize, and I'm going to give those people a shout out in my next video. So anticipate, right? Anticipate. And the winners are going to hear their names in the next video of episode 7, which is Cartesian product of a set. Do not forget to subscribe, share with your mates, and I'm going to give you more updates. Bye bye.